Hello everyone, thank you for joining me today for this lesson about classifying polynomials. We have two objectives today. We are going to simplify polynomials by adding, subtracting, and multiplying. We're going to classify polynomials by degree and number of terms. So what are these polynomials? Well, the word polynomial means many terms. So these are expressions that are made up of many terms, terms that are separated by addition and subtraction symbols. So we have some examples here on the screen that you can see. In the bottom left, 3x squared is a polynomial. Is actually a monomial, and we'll talk more about that word in a little bit. 3x squared plus 6x minus 15 is a polynomial as well. We can have multiple variables like you see in the example in the middle of the screen there. On the far right, you see a couple of expressions that are not polynomials. They have negative exponents, and we have a rational expression there as well. Expressions such as those are not technically polynomials. Now, these are all examples of polynomials as well. And here we're going to practice simplifying them, putting them in standard form. A polynomial is in standard form when its terms are organized in order from highest exponent to lowest exponent, biggest to smallest. And in order to put those terms in order, we may have to combine any like terms first, or maybe do some multiplication, some distribution, some foiling potentially. Then we can see how our exponents compare to each other. So let's start here with 4x plus x plus 2. We're going to put that in standard form. We'll start by combining any like terms because I don't see any multiplication that has to be done here. I'm looking at 4x and x and combining those to give us 5x plus 2. In terms of putting this in standard form, this is 5x to the first power. This 2 is a constant. It would be like x to the power of 0, really. And so my exponents already go in order from biggest to smallest. So 5x plus 2 is in standard form. X squared plus 3x minus 4x cubed. I don't see any multiplication that has to be done. We don't have any like terms because all three of these terms have different exponents, but we do have to shuffle them around to make sure their exponents go from biggest to smallest. So the biggest exponent I see there is a 3, so our first term here in standard form would be negative 4x cubed. Next, we have a positive x squared. Finally, 3x to the first power. There we have it in standard form. Over here, b squared times b minus 1. This time we've got some multiplication that needs to be done in order to put this in standard form. B squared times b, that would be b cubed. B squared times negative 1 will be negative b squared. And let's check our exponents, make sure they go from biggest to smallest, and as it turns out, they do. You might find that you naturally, in the flow of your work, just kind of already have terms in order from biggest to smallest, because that's kind of the convention that you've maybe been practicing in previous classes as well. So a polynomial is in standard form when its terms go from biggest exponent to smallest exponent. You may have to combine like terms, maybe multiply, before you can put a polynomial into standard form. Now, one of our big objectives today is classifying these polynomials. And there's two ways that we can classify a polynomial. We can classify a polynomial based on its degree or its highest exponent. We can classify a polynomial based on how many terms it has. So there's a lot of vocabulary terms on the screen here. I won't read through every single one. You can pause, write down whatever you need to do. But just a few examples here. A polynomial of degree 0 is constant, like 2 earlier in our lesson today. Something with an exponent of 1 is considered to be linear, like y equals mx plus b, a linear function. Degree 2 is quadratic. We saw those in a previous chapter, those quadratic functions where the highest exponent was 2 with an x squared. And you can see the rest of them there. Once we get up to a degree of 5, there's not really special names anymore. We just say 5th degree, 6th degree, etc. In regards to classifying based on the number of terms, a polynomial with one term is considered a monomial. Think about that prefix mono, like a monocle having one lens, perhaps. A polynomial of two terms would consider to be a binomial. Think bicycle, 2 wheels, perhaps. A polynomial of 3 terms is a trinomial. Think of triple or triangle with 3 angles, perhaps, that prefix tri. Any more than 3 terms, 4, 5, 6, 7, we just generically call those expressions polynomials. That prefix poly means many. There are many terms here. Polynomial is the big overarching term for us today. Monomial, binomial, trinomial are more specific words. We'll get a little bit of practice with this as we progress through the rest of this. So we're going to do kind of two things at once here, two objectives at once. We're going to practice simplifying, we're going to practice writing a standard form, and now that we've got this vocabulary, we will practice classifying these polynomials as well. So consider this expression here. We are adding these two polynomials together. These parentheses are really not necessary because this is an addition problem after all, right? So we can go ahead and combine like terms. I see a negative 8d cubed and a negative d cubed. Now there's negative 9d cubed here. All right, searching for other like terms that we can combine, I see a negative 7 and a negative 6. That will give us negative 13. Now notice that I already have the exponents in order from biggest to smallest. Again, you might just kind of naturally do that in the flow of your work. But let's practice classifying this now, and let's classify based on degree first. The highest exponent we see here is 3, and a polynomial of degree 3 is considered to be cubic. Now, based on the number of terms, this polynomial has 2 terms. Think of the prefix bi, like a bicycle with 2 wheels. This is a cubic binomial. Cubic is the adjective here, binomial is the noun. This is cubic binomial. To say binomial cubic would be a little bit strange. This is a cubic binomial. Here on the right-hand side, we've got to be a little bit more careful. We do have a subtraction problem here, so now these parentheses are actually relevant. But let's take this minus sign and let's distribute it across here. So then we have negative a squared minus 3. Now minus 3a. This is a negative times a negative a squared, so a positive a squared. A negative times a minus 5, so that's a plus 5 there. Now let's go ahead and combine like terms. I see a negative a squared and a positive a squared. That will cancel out. I see a negative 3a, and that's the only linear term that we have. A couple of constants here that we can combine. Negative 3 and positive 5 makes positive 2. Again, already have it in standard form. Exponents go from biggest to smallest. This is 2a to the first. This would be like 2a to the power of 0. Exponents are going from biggest to smallest there. Let's classify. The biggest exponent we have is a 1, and that makes this a linear polynomial. But even more specific than the word polynomial, once again, we've got 2 terms here. This is another example of a binomial. So here is a linear binomial, negative 3a plus 2. So there we got a little bit of practice adding, subtracting, classifying, putting in standard form, but we haven't seen maybe perhaps enough multiplication yet. So that's what I want to end with here today, is a little bit more multiplication. We've already seen some distribution earlier in our lesson. Here we have some different types of multiplying, so some foiling, some expanding, if you will. The directions are still the same. We're going to simplify, combine like terms, put in standard form, and then we'll go ahead and classify. But we're going to kind of stretch our multiplication skills here. So let's look at 3y plus 4 times y squared minus 5. This is a multiplication problem, and when we multiply 2 binomial expressions together, we are going to FOIL. So 3y times y squared gives 3y cubed. 3y times minus 5, that's minus 15y. Now the insides, 4 times y squared is 4y squared. The last 4 times negative 5, that gives negative 20. Now that I've done the multiplication, those parentheses go away, and I can rearrange these terms, combine any like terms we might have. We actually don't have any like terms here, but we have to rearrange to put our exponents in order from biggest to smallest. Our largest exponent is 3, so this cubic term comes first. Then we've got an exponent of 2, that's our quadratic term there. Now we've got negative 15y to the first, so our linear term comes next. Finally, our constant term at the end, this minus 20. Let's classify. The highest exponent I see is 3, so this is a cubic expression. There are 1, 2, 3, 4 separate terms here. The word we would use there is polynomial. 4 or more terms we consider generically a polynomial. This is a cubic polynomial. Let's take a look at n plus 3 squared. One of the most common algebra mistakes I see when taking a binomial and squaring it is an individual just taking n and squaring that, 3 and squaring that, and saying that their answer is n squared plus 9. Not the case though. Okay, we don't want to do that there. We don't end with n squared plus 9. If we end with n squared plus 9, we're missing some terms. Remember what it means to square an expression. We square an expression by multiplying it by itself. So n plus 3 squared literally means n plus 3 times n plus 3. And when we write it out, perhaps now we can more clearly see that we have to FOIL here. N squared, 3n, another 3n, 3 times 3 is 9. Now we can combine the two like terms in the middle. The wrong answer up here is missing that 6n in the middle that we would have. Standard form, we already have that. We've got n squared, 6n to the first. This would be like 9n to the power of 0. So our exponents do go from biggest to smallest. Let's classify here now. I see a highest exponent of 2. The word to use there is quadratic. There are 1, 2, 3 terms here. This is our first example of a trinomial today. That prefix tri meaning 3. 3 terms, trinomial. Let's end with k minus 1 to the power of 3. Now here again, the incorrect way to do this would be to just take k cubit, negative 1 cubit, and call it a day. Remember, to cube an expression means to have 3 factors of that expression. K minus 1 times k minus 1 times k minus 1. So we have to expand this product. We've got to multiply all of this stuff out. There's no single correct way that you have to go about this, but I can give you some advice about a way to kind of keep yourself organized. And that advice is this. Let's take 2 of these factors and let's FOIL them together, right? Let's maybe take these 2 and let's FOIL these 2 together. I'm going to do some FOILing in my head since I'm running out of room. If I FOIL k minus 1 times k minus 1, I'll end with k squared minus 2k plus 1. That's after I FOIL and combine like terms. Now, I'm not quite done multiplying yet. I've got to multiply this binomial by this trinomial, and FOIL wouldn't be the best way to describe that because then we'd be missing this term right here. So I prefer to think of it as distribution. I'm going to take each of these terms and distribute them across that trinomial and combine like terms to get my final answer. Now, as I go through it, I like to organize my work and kind of keep my like terms organized. You'll see what I mean here in a moment. So k times k squared will give us k cubed. Now k times minus 2k, that's minus 2k squared. K times 1, that's going to be a positive 1k. So I have taken this k and distributed it through. I'm done with that. Let's take the minus 1 and distribute that through. Negative 1 times k squared will give me a negative k squared. Now my preference is to stack up these like terms. So I'm going to put it right underneath that other quadratic term. Negative 1 times negative 2k is positive 2k. Negative 1 times 1 is negative 1. And now I have those like terms stacked up and ready to go. I've got k cubed. This would be minus 3k squared. This would be a plus 3k minus 1. Standard form, we already have exponents for those k variables going from biggest to smallest. Let's classify here. The highest degree we have is cubic. There are 4 distinct terms here, 4 or more terms. We call those polynomials. So this is a cubic polynomial. If you're wondering whether there would be a pattern to kind of speed this up a little bit, there is. It's something called the binomial theorem, which you may or may not learn about going forward. It's a little bit beyond what we need right here, but there is a pattern to take something and expand it to a power like we did here. So, in this first lesson of this chapter 6, we classified polynomials, we put polynomials in standard form, we simplified some polynomials by adding, subtracting, and multiplying. That's it for today. Thank you very much for watching.